Most of the mistakes we make in thinking begin with a simple illusion. Two things appear connected, so we assume one must be causing the other. It feels logical, it feels obvious, and it feels reassuring to believe we've discovered a clear explanation for how the world works. But what if that sense of certainty is the real trap? What if some of the strongest patterns we see in data are nothing but coincidences wearing the mask of truth? In this episode, we're going to peel that mask off. We're going to look at why our minds confuse correlation with causation, why so many viral headlines mislead us, and how a few simple tools can help us cut through the noise. If you've ever wondered why people jump to the wrong conclusions, or how to think more clearly in a world overflowing with data, this is the place to start. Let's begin. There is a strange pattern hidden inside the world of data. A pattern so misleading that it has fooled scientists, journalists, investors, and everyday people for centuries. A pattern that looks like truth, but isn't truth. A pattern that feels logical, but quietly distorts how we think about the world. This pattern is the illusion between correlation and causation, and it begins with a simple, absurd question. What if I told you that the number of people who drown in swimming pools rises and falls almost perfectly with the number of films Nicolas Cage appears in each year? Or that cheese consumption correlates with the number of people who die by getting tangled in bedsheets? These are real data sets. They look convincing on a graph. They match almost perfectly. But they're also completely meaningless. This is the trap of correlation. And unless we understand it deeply, it becomes the fastest way to jump to wrong conclusions. About science, health, politics, money, and even our own lives. Today, we're going to slow things down. We're going to break down exactly why human beings confuse correlation with causation, why our brains fall for these illusions, and how a simple three-step thinking framework can help you see the world with clarity that most people never achieve. Let's begin with something fundamental. Humans hate randomness, and we especially hate unexplained events. If A happens right before B, our brain is wired to assume A caused B. This instinct once helped our ancestors survive. If you eat a strange berry and feel sick afterward, your brain concludes the berry caused the sickness, even if it was just coincidence. This instinct kept us alive. But in the modern world, it constantly misleads us. Because in today's world, almost everything correlates with something else. But only a tiny fraction of those correlations tell us anything real. So let's make the difference clear. Correlation means that two things move together. They rise together, they fall together, they fluctuate in a pattern. But that alone does not mean one causes the other. Correlation is simply a relationship. A pattern, a coincidence, a rhythm. Causation, on the other hand, is a chain of influence. A cause is B. There is a mechanism, there is logic, and there is evidence. If smoke appears when fire appears, that is causation. Fire creates smoke. But if ice cream sales rise at the same time, drowning incidents rise, that is correlation. Ice cream does not cause drowning. The hidden cause is heat. Hotter weather leads people to swim more. Hotter weather also leads people to buy more ice cream. The hidden variable creates the illusion. And it's this illusion that we must understand. Correlation can take many forms. Some correlations are accidental, some are driven by hidden causes, and some are reversed entirely. To think clearly, we need to understand all three. The first type is the accidental coincidence. Two lines on a graph happen to move together by pure chance. They might match for years, but there is no connection between them. Nicolas Cage does not cause drownings, and yet the lines match beautifully. If you didn't know better, you might believe the story the graph tells. Data can be persuasive even when it is meaningless. The second type is the hidden variable. This kind of correlation is extremely common. Two things seem linked, but both are caused by something else entirely. Imagine noticing that people who own more books tend to do better in school. You might assume owning books causes intelligence. But maybe the hidden cause is simply that families who value education buy more books. The books are not causing the intelligence. They are a symptom, not the cause. The third type is reverse causation. Here, you might think A is causing B when actually B is causing A. Consider the observation that confident people often succeed. Is it confidence that causes success? Or is it success that creates confidence? Or maybe both influence each other in a loop. Without careful thought, it's easy to mistake the direction of influence. These three traps, coincidence, hidden variables, and reverse causation, explain most of the confusion we have about data. But the question is, how do we know which one is real? How do we know when correlation is just a pattern, and when it reveals something deeper? The answer lies in understanding mechanisms. A mechanism is the invisible link that connects cause to effect. Fire heats wood. Heated wood produces smoke. This is a mechanism. Without a mechanism, correlation is weak evidence at best. Let's look at a real-world example that confuses millions of people: coffee consumption. Many headlines claim that drinking coffee makes you live longer. The data shows a strong correlation. Coffee drinkers seem to live slightly longer. But does coffee cause longevity? Or is there a hidden variable? Maybe people who drink coffee tend to be more socially active, or more alert, or more likely to exercise, or simply come from cultures with healthier diets. To claim causation, we need more than a pattern. We need experiments. We need interventions. When scientists test what happens if they force one group to drink coffee and another to avoid it, the picture becomes more complicated. The correlation may still be there, but the mechanism looks different. Coffee is not a miracle. It's part of a bigger lifestyle pattern. This is why correlation is often described as a whisper. It hints, it suggests, it invites curiosity. But alone, it does not speak in complete sentences. Causation is the full sentence, the complete story, the mechanism, the evidence, the consistent result. Let's explore more real-life examples where these ideas matter. Consider the common belief that increased screen time makes children less focused. At first glance, it feels obvious. More screens, less attention. But what if it is the opposite? What if children who already struggle to focus naturally turn to screens as a form of stimulation? What if children with attention challenges use screens because they provide predictable structure or entertainment? The correlation is real, but the direction of causation may not be what it seems. Or think about economics. When GDP rises, crime often falls. It's tempting to think that economic growth directly causes less crime. But maybe better education, improved social programs, or demographic shifts are the real causes. The economy might merely correlate with the deeper forces at work. Or consider health studies claiming that red wine improves heart health. Is it the wine? Or the fact that people who drink moderate amounts of wine often do so socially with friends during relaxed meals, in lifestyles that include more walking and more balanced diets? The wine is part of a pattern, but it may not be the cause. These examples show how easy it is to misinterpret the world, and how attractive simple explanations can be. But reality is rarely simple. So how can we think clearly? How can we avoid the trap? Let's build a 3-step framework. Step 1, ask if there is a plausible mechanism. If someone claims that eating blueberries improves math scores, what is the mechanism? If there is none, the claim is suspicious. Real causation has a pathway. If the pathway is missing, the story is likely false. Step 2, look for hidden variables. Could something else be influencing both things? Could a third factor explain the relationship? Hidden variables are everywhere. They create illusions. They create stories that feel real but are not. Step 3, examine interventions. What happens if you change A does B actually change? If researchers manipulate the variable and the effect disappears, the correlation was misleading. If the effect remains, causation becomes more plausible. Interventions reveal truth where correlations only hint. This framework is simple. but incredibly powerful. Because misunderstanding causation is not just a scientific error. It is a human error. It is how conspiracy theories form. It is how marketing manipulates people. It is how misinformation spreads. And it is how we make poor decisions in our personal lives. We want simple answers. We want certainty. We want to believe that if two lines move together, they must be connected. But the world is more complex. And seeing that complexity clearly is one of the most valuable skills we can develop. Correlation is a clue. Causation is a conclusion. And the journey from one to the other requires thought, evidence, and humility. If you take only one idea from this episode, let it be. This correlation is the beginning of inquiry, not the end. It invites questions, but it does not settle them. Real understanding comes from asking, why not just observing what? The difference between believing a pattern and understanding a cause is the difference between being misled and thinking clearly. And now you think clearly. Script ends. The world is full of patterns. Some reveal truth. Others disguise it. Correlation is the first hint, the whisper that tells you something might be happening. But causation is the real story underneath. And learning to separate the two is one of the most important skills you can develop. It protects you from false confidence, from misleading headlines, from faulty logic, and from decisions built on shaky foundations. More importantly, it gives you the power to see what others overlook, the hidden forces, the real explanations, the deeper mechanisms that shape how things actually work. If this episode helped you think a little more clearly, consider joining me for the next one. We explore the unseen structures behind everyday ideas and why understanding them changes everything. Until then, remember, don't just look for patterns, look for causes. That's where clarity begins.